Hello, everyone, and welcome to today's program from MOS Live called Virtual Planetarium Exploring Space. My name is Emily, and I will be your moderator today, which means that I will be the one actually watching the Q&A box, because that Q&A box is the only way that you will be able to communicate with myself and our educators today. So if you have any questions or comments throughout the program, throw them into that Q&A box and I will relay that information to our main educators today. And I think, let's see what else. Okay, we are also offering closed captions during this program. So if you would like to see subtitles, just click on the closed caption button, which is somewhere on your screen, and then select show subtitles. And with that, we can get started. Have fun, everyone.
Hello, everybody. My name is Talia. I use she, her pronouns, and I'm going to be your presenter today. But all I do is the talking. I need somebody to help me out with the visuals.
Hi, everyone. My name is Katie. My pronouns are she and her, and I will be providing the visuals today.
And today, of course, is the 1st of June, which means we are kicking up a new theme for our Exploring Space webinars for this month. And this month is all about galaxies. June is Galaxy Month. So we're going to start off today with a bit of history of how our view of galaxies has changed over time. I couldn't resist starting with this visual. This is my favorite galaxy. This is M51, or the Whirlpool Galaxy. I think it's one of the prettiest ones in space. Now, galaxies, of course, are something that our view of has changed a lot over time. As astronomy has progressed and as we've developed new tools, but there is one galaxy that you can see quite prominently pretty much anywhere you have a dark sky, and that is our own, the Milky Way. So here's an image of the Milky Way at night from a very, very, very dark site. And this was very prominent in ancient skies because, of course, there wasn't really any light pollution back then. It has been described through various cultures as a river, a road, the seam along which the two halves of the sky are stuck together, and the legend from which it gets its name, a stream of spilled milk. In fact, the word galaxy comes from galaxius, or milky circle, which was a Greek name for the Milky Way. And even people weren't exactly sure what the Milky Way was. They did have all these stories about it, but even going back to ancient Greece, there's an idea that the Milky Way might be made up of lots and lots of stars. So here is a more realistic view of what the Milky Way would have looked like at night from a really dark site. You can still find places in the world where you can see a view like this. This is a view from North America. And so this is what they were looking up at. And in this view, you can see why they weren't quite sure what it was. It definitely looks different from the space around it. But like I said, going back to ancient times, there were people who thought maybe it was just a very thick concentration of stars, that there was a lot of stars in this particular part of the sky. Now, it was not until the 1610s that we were actually able to confirm this. And that's because in the 1610s, the telescope was invented. And a guy named Galileo took a fairly rudimentary telescope, that tube thing on the right, that is a model of the telescope he used. And he, as far as we know, is the first to think of pointing a telescope at the sky. This allowed him to do things like discover the moons of Jupiter and the rings of Saturn. And it also meant he got the first magnified view of the Milky Way and was able to confirm that it is, in fact, made up of many, 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 many stars. Now, at this point in history, when we say Milky Way, it basically means the same thing as universe. The concept was basically the same. The idea that everything in the sky that you could see was a part of the Milky Way, which basically meant Milky Way and universe were the same thing. So that meant that, of course, all the stars that we could see were part of the Milky Way, but it's not just stars that you can see in the night sky. Again, going back to ancient times, people were able to see certain things in the sky that looked different, that were not stars, cloudy things. So we called them nebulas. Nebula means cloud. These include things like the large and small Magellanic Clouds, which you can see from the southern hemisphere. And from here in the Northern Hemisphere, something that we called the Great Andromeda Nebula. Now here is a sky that you might see here in the Northern Hemisphere in the autumn. Is a good time to see this particular sky. And it's kind of hard to pick out, but near the center there is a little cloudy thing, just a little bit hard to pick out, but that's it. You can see it with your naked eye from dark sites. You can see it with binoculars from even pretty light polluted sites. This is what they called the Great Andromeda Nebula. And so from ancient times, people did know that there were these non-star things up in the sky. And then when telescopes became a thing, it became apparent that there were many cloud-like nebula objects in the sky, many, many nebulas. And they had different types of shapes. Some of them were very, very nebulous, in fact, very blob-like. Some of them seemed to have structure to them. And some, like the Great Andromeda Nebula, had elaborate spiral patterns. And we actually have a photo of the Great Andromeda Nebula from 1899. This is one of the first photos that was ever taken. And you can see this object has structure to it. This is one of what we started calling spiral nebulas because there appeared to be a spiral pattern in it. So we know that there are these cloudy, nebulous objects in the sky that we're calling nebulas, and some of them definitely have structure to them. They're not just amorphous blobs, they have a shape. And some of those shapes are spirals. And so we call those the spiral nebulas. And again, going back several hundred years, back to the 1700s, there were folks who had the idea that maybe these spiral nebulas like Andromeda, maybe they weren't all part of the Milky Way. Maybe they were, in fact, their own collections of stars, their own Milky Ways, in fact. Because again, at this point, we're into the 1700s now and going through the 1800s. Even as late as 1899, when this photo was taken, we are still at a point where the Milky Way and the universe are basically the same thing. So now we're up to the early 1900s. This is when things start to take some steps forward in terms of how precisely we can measure things. So this is a case where increased ability to measure things led to new ideas. And that's one of the things that really drives science forward, is this progression in technology, in detection methods, and that leads to progressions in ideas. So in the 1900s, people started to be able to make more precise measurements. And some of these measurements started to suggest that maybe these nebulas were too far away to be inside the Milky Way. So for instance, in 1912, a guy named Vesto Slipher, which is a very fascinating name, he looked at these nebulas and he looked at their Doppler shifts. Now, you've all heard Doppler shifts. If you've ever heard a police car go whizzing by you and the pitch of the siren sounds different, that is a Doppler shift. Basically, it means that things moving towards you, you're going to hear the sound at a higher frequency, and as it moves away, you're going to hear it at a lower frequency. The same thing happens with light. So this is one of the ways astronomers determine how things are moving out in space, by looking at the frequency of the light. If the light appears to be what we call blue shifted, that means we're seeing light at higher frequencies. It means the object is moving towards us. If you see it what we call red shifted, that means the light is at lower frequencies, longer distance between the waves, higher wavelength, and it means it's moving away from us. So Vesto Slipher, he of the very fascinating name, he looked at these nebulas and he figured out that they have very high Doppler shifts, way higher than he saw in the stars that he could see in the sky. So that means those nebulas were moving way faster than the stars were. And moreover, they all seemed to be moving away. They were all redshifted. with the exception of Andromeda. Again, Andromeda, always the odd one out. So that would suggest that these nebulas mostly are moving at pretty high speeds away from us, where we were viewing on Earth. And that's not what we see with the stars around us. So that suggests that they might be not living in the same place. They're maybe not all part of the Milky Way. Another big clue were things called novas. Now, who here has heard of a nova in some form? Go ahead and put in the Q&A maybe where you've heard it before, or just a yes or a no if you've heard it or you haven't heard it.
So we're just giving folks a moment to type their answers into the chat. I have one person saying that they love novae, I should say, especially supernovae.
Yeah, supernovae are sort of the famous ones. Now, supernova, of course, are when a star explodes. So that is a specific kind of nova. A generic nova, if you just say a nova, it means the star got brighter for a variety of reasons. One of which could be that it blew up in a supernova. But so a nova is the brightening of a star for any one of a bunch of reasons. And again, in the early 1917, another guy with a fascinating name, Heber Curtis, looked at nova in a variety of these spiral nebulas, and in particular, the Great Andromeda Nebula. And he noticed that on average, they tended to be about 10 times fainter than the ones in the Milky Way. So that would suggest that it's the same kind of novas, they're just farther away, just like a flashlight in your face is a lot brighter than that same flashlight 500 feet away from you. So he suggested the fact that these nova looked so faint in the Milky Way, or in Andromeda, suggested that Andromeda was really, really far away, too far away to be part of the Milky Way. And he started using a term that actually has its roots in philosophy from a philosopher named Immanuel Kant. He started calling them island universes. So instead of spiral nebulas, he started calling them island universes, which I love as a term. I think it's very poetic. Now, this was a pretty big claim to make. He made it again in around 1917, and it caused a huge amount of division in the astronomy community at the time. So what do you do when you have that? Well, in 1920, a whole bunch of astronomers got together at the Smithsonian for what they called the Great Debate, in which Heber Curtis put forth his reasons for why he thought these island universes were their own things, that they weren't part of the Milky Way. And a guy named Harlow Shapley argued that they were, in fact, all part of the Milky Way, and that the Milky Way was everything. Again, this is 1920. This is 100 years ago. This is not ancient times. This is relatively recent in terms of history. So Shapley said, basically, his arguments were that if Andromeda was the same size as the Milky Way, it would have to be millions of light years away. And obviously, the universe isn't that big. Spoiler alert, it's way bigger than that. Andromeda is millions of light years away. And his other argument is that they saw a nova in Andromeda briefly outshine the entire nebula. And there's no way a nova could possibly outshine an entire galaxy. Well, guess what? Now we know they can. In fact, that's what a supernova does. Supernovas can outshine entire galaxies. So Shapley was making the argument based on what he knew at the time. We now know his arguments were wrong. Of course, Curtis had his arguments about the nova. He had Mr. Vesto Slipher's Doppler shifts. And he also had things like the fact that Andromeda looks like it has dust lanes, just like the Milky Way does. So all of that suggests that maybe that the current thinking was wrong. Maybe it was time to rethink our view of the universe, and that these island universes were in fact other galaxies. so that the Great Andromeda Nebula maybe was in fact the Andromeda Galaxy. Now, this debate was very, very interesting for astronomers at the time. It didn't really make a difference. People were still debating. There was still no definite answers to which of these gentlemen was making the correct arguments. Of course, today we know which one was, but in 1920 we really didn't. So along comes Hubble. Nope, not this Hubble. This is probably the Hubble you think of when you think of the word Hubble, but the amazing Hubble Space Telescope is named after a person. And so when I say along came Hubble, I don't mean the telescope, I mean the person, Edwin Hubble, the man for whom the Hubble Space Telescope was named. And he was sort of, doing his thing, and he looked at a certain kind of star in some of these nebulas, in fact, in Andromeda and another nebula called Triangulum. Now, these particular stars that he was looking at are called variables. So here's a picture. This is what we now see when we look through modern telescopes at Andromeda and Triangulum. And these stars he was looking at are called Cepheid Variables. And there are different kinds of stars out there that actually all change their brightness as they go through life. These are variable stars. And there's a particular kind called Cepheid Variables. And these are very, very predictable. We know based on how long it takes them to go through their brightness cycle, how bright they are. The two are connected. So we can look at a star that's doing this off in the distance, and we know based on how long it takes it to go through its brightness cycle, we know how bright it actually got, even if it didn't look that bright to us because it was really far away. So once you know exactly how bright the star really is, you can take a look at how bright it looks to you and guess how far away it is. It's the same thing as, again, if I had a flashlight and I showed you it close up, you know how bright that flashlight is, you would then be able to take a rough guess, at least, if I, ran off into the distance with it, how far away I was, based on how dim that flashlight looked. So based on how bright or how dim these Cepheid variables looked, Hubble figured out how far away they were. And he was looking at ones in these nebulas, Triangulum and Andromeda. So he figured out that they were, in fact, millions of light years away. Now, just to use a modern measurement, we know that Andromeda is, in fact, about 2.5 million light years away from us. So that clearly meant they had to be outside of the Milky Way. We knew roughly how big we had an idea how big the Milky Way was, and it was not millions of light years. That meant these objects, these nebulas, they had to be outside of the Milky Way. That means they were their own island universes. And this was when we finally had proof that other galaxies existed. And our entire view of the universe had to change. And again, this is not something that happened, thousands or even hundreds of years ago. This was 1924. This was just under 100 years ago that our whole view of the universe had to be completely reworked, because we figured out that there were other galaxies out there, that the Milky Way was not the only one. So, science is really always having to change, and even huge things like our view of what the universe looks like has to change from time to time. Now, fortunately, today we have a whole bunch of new tool sets to bring to bear. This first image here, this is from a sky survey, which is called the Sloan Digital Sky Survey. These are projects that view the entire night sky over a period of time to map out everything that they can see. So that's invaluable in tracking where galaxies are. We also have telescopes that look in other wavelengths. So in wavelengths that the eye can't see. For instance, the Very Large Array, which is a giant radio telescope facility in New Mexico, or NASA's Infrared Telescope Facility, which is on a mountain in Hawaii. These look at the sky in wavelengths that people like Heber Curtis and Harlow Shapley couldn't look at. And that tells us so much more information. We also have space-based observatories like the Hubble Space Telescope, named again for Edwin Hubble, or the Chandra X-ray Observatory, which looks in X-ray wavelengths that you can't even see from the ground. You can only view those from space. And we are actually planning the next generation of telescopes, such as the James Webb Space Telescope or the Nancy Grace Roman Space Telescope, which are going to push the envelope of what we can view even farther and continuously update our view of the universe and the galaxies within it. Because remember back to just over 100 years ago when there was only one galaxy, and that was the Milky Way. That was it, the only galaxy there was. Now, in modern day, we think there are about 2 trillion galaxies that we can see in the visible universe. And for our final visual, I want to look at one of my favorite pictures, which is the Hubble Extreme Deep Field. This is again from the Hubble Space Telescope. So Edwin Hubble's namesake, continuing to rock our universe. This is a single image. And I always like to ask people, how much of the sky do you think is in this image? Go ahead and put in the Q&A, how much of the sky do you think this image covers? Take a guess.
They're thinking, Talia. All right. So I see one number that popped up in the chat, but it would be helpful to have some units in there as well. Let's see. Someone said maybe 100,000 light years. I think someone put in like 100 million, maybe. Lots of different answers in there.
Well, this image, in fact, in almost every single point of light in this image is a galaxy. And this image covers 1/32 millionth of the sky. So if you were to divide the sky up into 32 million chunks, this would be one of those chunks. It's about the same as if you took a dime in your hand and held it all the way out at arm's length. The amount of sky covered by this image is about the same that would be covered by the eye on the head of the dime as you held it out at arm's length. This is an extremely tiny patch of sky, and it has over 5,000 galaxies visible in it. And that's less than 100 years after we were debating whether or not there was only one galaxy. So as science has progressed, our entire view of the universe has had to change. And that's what science does. As technology progresses, we get better telescopes, we can discover things that we didn't know before, and we use that to completely change what we know about everything, including the entire universe and all of the galaxies in it. So I know I did a lot of talking about the entire history of observation of galaxies and the nature of the continuously changing nature of science. If anybody has any questions, I would love to answer them at this time. Feel free to put those in the Q&A, and I will do my best to answer.
Thank you, Talia. We do have a bunch of really great ones that came in. The most recent one is, could you tell us, or could you guess, how many light years across is that Hubble Deep Field picture that we're looking at?
So it's very, very few, like I said, it's a little piece of the sky, but if you consider going how deep it is, how deep into the universe you're looking billions of light years. Ouch.
Awesome. That's big.
Yeah.
Let's see. Okay, so another really great question was, when did countries start working together on research, maybe specifically for galaxies or just about, things in space in general?
That's a great question. And it's really the 20th century, I think, when people started really working together. Up until then, there were definitely scientists who worked together across international lines. It's not, as though that's a brand new thing. But there was almost a sense of competition within different countries that their country could make the most scientific discoveries. So you'd often have countries like England facing off against, English scientists facing off against French scientists, facing off against German scientists, all arguing, and everybody ignoring the American scientists because everybody knew they didn't know what they were talking about. So that was basically the state of things up until the 1900s. Once we reached the 20th century and everybody started having increased access to better instruments, better telescopes, then it became very, very common for groups of scientists to be international.
Cool. Someone is wondering if we were to pick what looks like a blank spot in the Hubble Deep Field image and zoom in even more, would we see more galaxies?
Quite probably, and that's one of the things that telescopes like the James Webb are hoping to do. They can see deeper than Hubble can. These future telescopes will be able to. And there's also, what we're seeing here are largely large, bright galaxies. The galaxies can be small and dim as well. In fact, that's one of the things we're going to start covering next week when Katie's going to tell you all about different types of galaxies.
Nice. Something to look forward to. How many galaxies are there in space?
So in the visible universe, the part of the universe that we can see with our telescopes, because we can't see the whole universe, we think we know of about 2 trillion visible galaxies. And that is, again, visible ones. There are ones in the visible universe that we can't see, either because they're too faint or because they're behind other galaxies or there's stuff in the way. So there may, in fact, be as many as 10 times that. We're not sure exactly.
Awesome.
The number is very large.
And Talia, I think this will be the last question. Have you ever been to space?
Very sadly, I have not. I would love to go to space, but so far, no.
All right. So with that, folks, we are officially out of time. I'm going to let Katie and Talia say goodbye to you all.
Bye, everybody.
Bye, everyone.
All right. And folks, like I said, we're out of time, but thank you all so much for your wonderful questions and comments in that chat box. If you are interested in seeing more of our virtual offerings, you can visit our website at mos.org/mos@home. And then if you enjoyed today's presentation, we welcome you to support the museum by visiting engage.mos.org/welcome. And with that, I hope you all enjoy the rest of your day, and we'll see you next time.